Dear students, welcome to Mathematics Online classes. Now we are going to solve problem number 9. Write the direction ratios of the vector. Here given vector is vector A is equal to I plus j minus 2k, and hence calculate its direction cosines. This is our question here. Okay, I told you direction ratios are nothing but scalar components of the vector. What are the scalar components of the vector? Scalar components are 1, 1 and minus 2. So, direction ratios are, or else what you do, you compare with comparing with vector r is equal to ai plus bj plus ck. This is general vector where a, b and c are direction ratios. And what about the direction cosines? Direction cosines we obtain by dividing direction ratios by the magnitude of the vector. Okay, fine. Here these are the a, b, c are the direction ratios. You know, in place of a, b, c, what is there here? A means 1, b means 1, c means minus 2. Therefore direction ratios are a is equal to 1, b is equal to 1, c is equal to minus 2. These are the direction ratios. And then direction cosines, they asked you to find out direction cosines. Direction cosines means you should divide direction ratios by magnitude of the vector. We know this as L is equal to A by magnitude of the given vector R. Here is R. Okay. Now this is again M is equal to B by magnitude of vector R, and N is equal to C by magnitude of vector R. A, B and C values we know. What about the R value? Let us calculate R value here. R is magnitude of the vector, that is square root of a square plus b square plus c square, where a, b and c are scalar components of the vector. Here scalar components are 1, 1, minus 2. Now this is square root of 1 square plus 1 square plus minus 2 square. So this is square root of 1 plus 1 plus 2 square is 4. This is square root of 6. What is this? This is a magnitude of the vector. Now direction cosines, I am writing it here. L is equal to A is 1 by magnitude of vector R, 1 by square root of 6. M is equal to, again it is 1 by square root of 6, and N is equal to, C value is minus 2 by square root of 6. Therefore direction cosines are, LMN is equal to, I will write it like this: 1 by square root of 6, 1 by square root of 6, minus 2 by square root of 6. This is the answer for the given example. Yes. Now we will move on to the next heading, that is vector joining 2 points. Vector joining 2 points. Up to here in the chapter vector algebra, whatever the vectors we have used, all those vectors are position vectors, in the sense where initial point is origin and terminal point is the given point. Here vector joining 2 points, in the sense initial point and terminal point both are points here. Okay. let me consider a 3-dimensional plane like this. I have a 3-dimensional plane with x axis, y axis and a z axis. I have 2 points here. This is first point A and this is second point B. There is a vector joining these 2 points, that is a vector AB. What is this vector AB? We are going to find now. What is this vector AB? Let me take coordinates of first point A as x1, y1, z1 and coordinates of second point B as x2, y2, z2. Okay. From the origin O, if we join the first point A, that will be the position vector of the first point A. That is position vector of first point A. Let me take this as vector A. Then what about the position vector of point B? If we join origin to the second point B, this is position vector of the second point that is B. Let me take it as a vector B. You should write a straight line here. Fine. Now I hope you know, if A has the coordinates as x1, y1 and z1, then position vector of point A will be written as vector OA, where vector OA is nothing but x1i plus y1j plus z1k. Then what about the position vector of the point B? Position vector of the point B will be represented as a vector OB. Vector OB, it has the coordinates x2, y2, z2. Hence, position vector of point B will be x2i plus y2j plus z2k. It is. Now, let us write what is vector AB. Here, you need to write something in the words, that is, let A of x1, y1, z1 and B of x2, y2, z2 are the 2 given points. Position vector of point A is vector OA is equal to, that is x1i plus y1j plus z1k, and similarly position vector of point B is vector OB is equal to x2i plus y2j plus z2k. It is. Okay, fine. Now you see, from the diagram I can write, from the figure, what we can write here? This OAB, is it a triangle or not? OAB is a triangle. I will use triangle of vector addition here. From the figure, using triangle of vector addition, you see, OA is the first vector, AB is the second vector. So we can add these two. Terminal point of first vector is getting coincide with the initial point of second vector. So according to the triangle of vector addition, I have vector OA plus vector AB is equal to vector OB. Now take this vector OA to the right hand side. We have vector AB is equal to vector OB minus vector OA. What does it mean? It means that a vector joining 2 points A and B, where it is directed from A to B. Directed from A to B in the sense, A is initial point, B is a terminal point. Okay. A vector directed from A to B is equal to position vector of second point minus position vector of first point. Position vector of terminal point minus position vector of initial point. Like that we need to consider. So now vector AB is equal to, what is this OB? OB we know it as x2i plus y2j plus z2k minus of position vector of first point, that is vector OA is x1i plus y1j plus z1k. Now just it is subtraction of two vectors in component form. Vector OB is equal to, how we subtract it? We subtract it component form. I component we will subtract, j component we will subtract, similarly k components also. x2 here minus x1, this is x2 minus x1 into I cap plus, here y2 is there, minus will get multiplied, minus y1, this is y2 minus y1 into j cap plus z2 minus z1 into k cap. What is this? This is a vector joining two points A and B, which is directed from A to B. Yes, like this we need to take. Then what about the magnitude of the vector? What about the magnitude? Magnitude of vector AB, this is equal to, here it is similar to the previous case. If suppose we have a vector as AI plus BJ plus CK, AI plus BJ plus CK is the vector, then what is its magnitude? Its magnitude is square root of A square plus B square plus C square. So here also magnitude of vector AB is, this is square root of, in place of A x2 minus x1 is there, in place of B y2 minus y1 is there, in place of C z2 minus z1 is there. So magnitude of vector AB we will write as x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. This is the formula to find out magnitude of a vector joining two points. This is about a vector joining two points. Okay, now let us take example number 10 here. Example number 10 is, it is given as, find the vector joining the points, find the vector joining the points, find the vector joining the points P of 2, 3, 0 and Q of minus 1, minus 2, minus 4, directed from P to Q, directed from P to Q, directed from P to Q. What does it mean? Directed from P to Q means, here initial point is P, terminal point is Q. Okay, I need to find out vector PQ here. If it is given as directed from Q to P, then I have to find out vector QP. Here it is directed from P to Q, vector PQ we need to find out. What is vector PQ is equal to? Vector PQ is equal to position vector of Q minus position vector of point P. So vector PQ is nothing but vector OQ minus vector OP, simple one. What is vector OP and vector OQ here? Those are the position vectors of the points. P point has the coordinates 2, 3, 0. Therefore, we have the vector OP as, here we will write like this, here position vector of the point P, vector OP is equal to 2, 3, 0, you know. So this is 2i plus 3j plus 0k. Okay. Even if you write up to 2i plus 3j, it is enough. Next, what about the vector OQ, that is position vector of the point q, it has the coordinates minus 1 comma minus 2 comma minus 4. Therefore its position vector is minus 1i minus 2j minus 4k. Then vector pq is equal to vector oq minus vector op. What is vector oq? Vector oq is minus 1i minus 2j minus 4k minus of vector op is 2i plus 3j plus 0k. Now let us subtract these two vectors in component form. This is minus 1i, here minus into plus, minus 1 or minus 2, this is minus 3i, minus 2 and here minus 3 means minus 5j, minus 4k and minus 0, that has no value, so it is minus 4k. What about the vector directed from p to q? This is minus 3i minus 5j minus 4k. Yes, now we will move on to the next section, that is a section formula. Section formula we are going to derive in case of vectors. First of all, I will remind you what is that section formula you have studied. You have studied the section formula in 3-dimensional plane also, in case of means 3-dimensional geometry during your first PU, and also in SSLC you have studied in coordinate geometry chapter. I will remind you once. See, suppose there are 2 points A and B, line segment is there, line segment is joining these 2 points. Let us take A coordinates as x1, y1, z1 and B coordinates as x2, y2, z2. Suppose there is a point P which divides AB in the ratio m is to n. What does it mean, this m is to n? Is that AP is equal to m length here? No, AP is equal to m length, we should not consider like that. AP and PB are in the ratio m is to n, means if you divide this AB segment into m plus n parts, then m parts are there on the left side of the point P, n parts are there on the right side of the point P. That is the meaning. That is the meaning. See, suppose the AB length is around 10 centimeter. AB is equal to 10 centimeter. Now, AP, let us take it as 4 centimeter, and obviously PB will be 6 centimeter. Then what is this? AP by PB is equal to, AP by PB is equal to 4 by 6. M is to n, we will not write it as 4 is to 6. We will write it as 2 1s, 2 3s, we will write it as 2 is to 3. That means if we divide this line segment into 5 equal parts, 2 parts will be on the left hand side and 3 parts will be on the right hand side of point P. This is the meaning. This is the meaning. Okay, now what are the coordinates of the point P here? Coordinates of point P we will calculate using the formula mx2 plus nx1 divided by m plus n, comma my2 plus ny1 divided by m plus n, comma mz2 plus nz1 divided by m plus n. If we consider only 2 coordinates, we should write up to here. This is what the concept you have studied in case of algebra part. Okay. Now we will go to the section formula here. Same thing we are going to do here also. Section formula, 2 cases we need to consider. First case is when internal division and another one is external division. Okay. Now let us take first case internal division. Internal division means what? Let me take 2 points A and B. It is joined by a line segment. Here we are going to deal with the vectors, Let us take a vector AB. It is directed from point A and it is terminating at a point B. Okay. Now here is origin for us. This is O. Here is a origin. If I join O and A, this is what? This is a position vector of point A. Let me take a position vector of point A as a vector A. Here position vector of point A we are representing as a vector A. Then let us join position vector of point B, means let us join O and B, then we have position vector of point B. Vector OB is equal to, let us write it as a vector B. Now there is a point P, on the vector AB which divides vector AB in the ratio m:n. Now we want to find out what is the position vector of point P. Here vector OP is equal to, let us take it as a vector R. This is equal to question mark. In terms of vector A and vector B, I have to find out. This is our question here. I am repeating once again. AB is a vector, A is initial point, B is a terminal point, and position vector of the point A is vector A, position vector of the point B is a vector B. Now there is a point P on the vector AB which is dividing the AB in the ratio m:n, dividing the vector AB in the ratio m:n. Then what is the position vector of the point P is our question here. What is the position vector of the point P? That one we need to find out. Okay, we need to write something in words, that is, this will be a 3-mark question, important question. Let AB is a vector, joining A and joining the points A and B. And again position vectors of point A, position vectors of point A and B are OA is equal to vector A and OB is equal to vector B. Now let us take, point P divides AB internally in the ratio m:n. Let us take point P divides AB internally in the ratio m:n. And again let me take position vector of point P is equal to position vector of point P is, let us take vector OP is equal to vector R. Okay, here almost I have written what are the notations I am using. If you write what are the notations you are using here, this is more than enough, no need to worry. Then P divides AB in the ratio m:n. What does it mean? It means we can write here, this is AP by PB is equal to m/n. AP by PB is equal to m/n. We can write like this. As it is a vector, I can write here, it is n into vector AP is equal to m into vector PB I can write. When n into vector AP is equal to m into vector PB I can write. Then n into what is vector AP? AP is a vector joining two points where initial point is A and terminal point is P. I can write AP as a vector OP minus vector OA, which is equal to m into. In the same way, what is vector PB? PB is a vector joining two points P and B, where initial point is P, terminal point is B. This is nothing but vector OB minus vector OP. This concept we have studied in under the heading vector joining two points. Now n into what is the vector OP? Vector OP we are going to find. We are taking that vector OP as a vector R. Vector R minus what is vector OA? Vector OA is a position vector of the point A. This is vector A, which is equal to m into vector OB is vector B minus of again vector OP is there, that will be vector R. N will multiply to both n into vector R minus n into vector A is equal to m into vector B minus m into vector R. We need to find out vector R here, so separate for vector R. Take this to the left hand side and this n into vector A to the right side. We have m into vector R plus n into vector R is equal to m into vector B plus n into vector A. What is common from these two? Vector R is common. Vector R into m plus n is equal to m into vector B plus n into vector A. Now we have vector R is equal to m into vector B plus n into vector A divided by m plus n. What is this? This is the formula to find out a position vector of the point P, which divides the vector AB in the ratio m is to n. This is the formula when point P divides the vector AB internally. Point P divides in the internally. Now let us take when the point P divides the vector AB externally. What happens to this? This will be same only, this will be same. Only thing is that let P divides AB externally. Only this one I am going to change. I will not rewrite it. Okay. There is a line segment AB and here is the origin O. If I join O and A, that will be the position vector of, it is directed from A to B only, you have to be careful, and this will be the position vector of point A. Let us take this as vector A. Vector OA is equal to vector A, and if I join O and B, that will be the position vector of the point B. It will be represented as a vector B. This is vector OB is equal to vector B. Now here I am saying that sorry, I did not change the heading. Heading should be external division. External division means what? Means point P is outside the vector AB. Point P is outside, but it is on the same line if we extend. Here is the point P. It is dividing externally. Means what? If it is dividing externally means this AP length is there, no? AP length will be taken as M and this BP length will be taken as N. Now if I join this O and P, that will be the position vector of the point P. It will be taken as a vector R. So position vector of point P is a vector R. You have to be careful. What is the difference between internal division and external division? here internal division means point P will be on the line segment AB and it will be dividing in the ratio m is to n. This AP is m and this PB is n. If it is dividing externally, vector AB is this and point P will be on the line AB if we extend it. Somewhere here will be the point P. This AP length, complete length will be taken as m and this BP will be taken as n. Here AP and BP will be in the ratio m is to n. In the same way again I can explain like if you divide the line segment into m minus n parts, like that you can explain this. Just you remember if this much, it is more than enough. Okay. Now same way here again, P divides AB. Here again let AB is a vector joining the points A and B. Position vectors of point A and B are vector OA is equal to vector A and vector OB is equal to vector B. Let point P divides AB externally in the ratio, we have to be careful here, externally in the ratio m is to n. So position vector of point P, let me take it as vector OP is equal to vector R. Here P divides AB in the ratio m is to n. What does it mean? It means AP by BP I have to take care. Why I am taking BP? Means this vector is directed like this. Vector is directed from left to right. Left to right it is directed. So I have to take like this. Vector AP by BP is equal to m by n. I can write this as n times vector AP is equal to m times vector BP. Okay. N into what is vector AP? Vector AP is a vector joining two points A and P. This will be OP minus OA, which is equal to m into BP is a vector joining two points B and P. So here P is terminal point, B is initial point. This will be OP minus OB. You can go with the triangle of vector addition also, no problem. Triangle concept also you can use, but I hope this way of writing will be easy. That's why I am saying. Let us explain. Vector AP is there. Here is vector AP. Here is vector AP and OAP is a triangle. OAP is a triangle. OA is the first vector. OA is the first vector plus AP is the second vector. Addition of these two will be vector OP. Addition of these two will be vector OP. See, you see, vector AP is equal to, again I am getting vector OP minus vector OA only according to the triangle of vector addition. But that is no need. Using the concept of vector joining two points, we can write this easily. N into what is position vector of point P, that is taken as vector R minus of vector A, which is equal to m into vector R minus vector B, that is position vector of point B. N will get multiplied with these two. N into vector R minus n into vector A is equal to m into vector R minus m into vector B. We want R here. We want R, so separate for R. Let me take this m into B vector to the left hand side. M into vector B minus n into vector A I will write as it is. N into vector R I will take to the right hand side. M into vector R as it is. I am taking this to the right side. So that is minus n into vector R. Okay. M into vector B minus n into vector A is equal to, what is common among these two? Vector R is common. So we have m minus n into vector R. Okay. Let me interchange LHS and RHS. M minus n into vector R is equal to m into vector B minus n into vector A. We have vector R is equal to m into vector B minus n into vector A divided by m minus n. Formula, what is the difference between internal division and external division? Only difference in formula is here plus was there in case of internal division, we have minus here. you need to use the formula properly. If they say point divides internally, then you use plus here. If it given as point divides externally, then minus comes. Derivation of internal division is more important compared to external division. Thank you. Problems on the section formula we will continue in the next class.